So, welcome back to the Bioenergy course. Today what we will be starting off with, we will be talking about the feedstock properties, okay, which is the D, which is feedstock properties. So, the different feedstock properties, what we will be dealing with, there are 4 different feedstock properties we will be dealing with. Again, the first one will be the moisture content. Next, we will be dealing with ash content. Third, we will be dealing with volatile compounds like terpenoids, volatile compounds, and the fourth we will be dealing with particle size. They are all interlinked to each other, particle size. Okay. These are the 4 parameters while we will talk about the feedstock properties. And just previously, in the previous section, we talked about what are the treatments. Again, in the treatment is also function of the moisture, alkali metals, and the particle size. Okay. So, now let us talk about the moisture content while we talk about selecting the feedstock properties. So, in terms of the efficiency, we talk about, let us talk about the moisture content. Okay. So, it significantly influences the performance of the gasifier. Gasifier performance is significantly influenced by the moisture content. Okay. So, now fuel with moisture content about 30%, a few critical points you need to remember. Fuel with moisture content of 30% make ignition difficult and leads to lower calorific value. Difficult and have, I am just putting downward arrow for the low calorific value, okay, of product gas. So, one has to ensure that this level is below 30%, okay, due to the need to evaporate the additional moisture before combustion. So, that essentially brings us that this needs to be evaporated out in order to raise the calorific value. So, you are seeing that all these things are linked to each other, like you cannot do one thing by missing out on another. The second aspect what is important is that suppose say for example, you have a higher moisture, okay. Higher moisture content will lead to a lower temperature in oxidation zone. It leads to lower temperature. So, higher moisture leads to lower the temperature, leads to lower temperature achieved in oxidation zone. So, we will talk about this oxidation zone, we will talk about the gasifier design and everything. Okay. This situation, this lowering of the temperature in the oxidation zone leads to a or resulting into incomplete cracking of the hydrocarbon released from the pyrolysis zone, resulting in the incomplete cracking of the hydrocarbon released from the pyrolysis zone. So, from the pyrolysis zone. So, here let me highlight something. There are some few words which are coming like pyrolysis zone, oxidation zone and likewise and so forth. Do not get worried because these are the different in the gasifier there are different locations where pyrolysis is taking place, gasification is taking place, from where the tars and the volatiles are coming out. So, these words when we talk about the pyrolysis zone, we talk about the oxidation zone, these are the different spatial location within the gasifier. Okay. So, just for the time being before we get into the gasifier schematics of the gasifier, just accept these words. As soon as we will get into the gasifier section, everything will be clear what I meant by in the pyrolysis zone, which one is the oxidation zone. Okay. So, coming back, so this will lead to the incomplete. So, critical point, a take home message here is that incomplete cracking of the hydrocarbon. This is what is the most critical aspect in the pyrolysis zone, and this further leads to something very interesting. Higher level of moisture, higher. So, this arrow is again the same arrow, higher level of moisture and the presence of carbon monoxide produces lot of hydrogen into the system, okay, by the, this is interesting because this is something which is a repetition now what I have covered in the chemistry, water gas shift reaction. So, just let me take you back to that reaction where we talk about water gas shift reaction somewhere here. Look at this reaction. This is the water gas shift reaction. You remember in the previous class we talked about it, that here you have the CO, you have the water. So, they are all linked, CO2, and I showed you that this CO in the presence of 3H2 forming the methane is the same chemistry. So, remember one thing, though these are very vast kind of voluminous topics, but it is actually the basic chemistry. If your basic chemistry is clear, so if this slide what I taught you people, two basic steps of combustion, if these two are clear, then the rest is all simple. You can vary, like think of it for a minute, you have forgotten everything. But if you know that this basic reaction C plus half O2 forming CO, C plus O2 forming CO2 and CO plus H2O forming CO2 plus H2 and CO plus 3H2 forming CH4. If you know these four reactions, look how logically you can rationalize it out. So, in every place you are seeing the arrow is bidirectional, right. So, it means all the things are in equilibrium. Okay. It can be dynamic process, reactant as well as a product may be equal, they can move dynamically, they can shift. Now, if some way or other you increase the reactant, what will happen? The reaction will move towards the right, there will be more product or vice versa. Okay. So, in other words, these four reactions, so if you see the parameters, so if you see all these things, so water content. So, if you increase the water, say for example, let us take this, if you increase the water content and if you can, there is a possibility you will have more hydrogen and CO2 forming on the right hand side. Similarly, out here if you increase somewhere, if you could increase the carbon monoxide, automatically the reaction will be shifting more towards the methane production, right. So, whenever you get confused, you should have your key, the critical, like what is the take home, how I could really get this whole philosophy clear in my mind. I have to remember the chemistry. It is all in that simple chemistry what is happening in nature. Anything which could pushes the reaction to the right will lead to more product, and anything which pushes the reaction to the left will have more reactant accumulating in one place. And you can vary them and you can play around with it and you can figure out how the reaction, of course, it is a limit, but that is a different story. But these are the four reactions which will govern it. Now, coming back where we just shifted gear. So, by shifting the water gas shift reaction, this is what you are doing essentially by shift reaction, and in turn what you are doing, and in turn the increase of hydrogen content of the gas produced, and it contains more and more methane by direct hydrogenation, addition of hydrogen. Okay. Hydrogenation, which is basically addition of H2. Now, if you again refer to that same reaction, you will see the same thing, what is happening. See, for example, like here CO, H2O making CO2 and H2, and this same CO reacting, this is that hydrogenation process, what I am just writing, CO plus 3H2 forming CH4. So, if you have higher concentration of CO here, if you have higher concentration of it, you will have higher concentration of methane. So, you are shifting the reaction towards right. So, the arrow will now be more on this side towards right. Okay. So, you have a more product out of this whole reaction. So, coming back where we were. So, this is how water is influencing. There is a third aspect to it in terms of the moisture content, the gain of hydrogen, the gain of hydrogen and methane CH4 of the product gas, okay, does not, however, just remember this, does not however compensate for the loss of energy due to the reduced level of CO, reduced CO content. Okay. So, the gain of hydrogen and CH4 of the product gas does not however compensate for the loss of energy due to reduced CO content. And if you reduce the CO content, what will happen? This particular aspect, reduced CO content, will lead to low calorific value. We have talked about this in the last class. Okay. So, you realize if you follow the basic reaction right, all those 4 reactions what we talked about, you can actually predict in which direction the reaction is going to move and what will be the stoichiometry, how you can compensate, what will be the calorific value of the product, what you will be getting. So, the next aspect into this, what we are about to add is the ash content, okay, or the mineral content. Okay. So, now we will talk about the ash content in terms of the parameters. So, in terms of the ash content, one of the biggest challenge is that higher the mineral matter, okay, higher the mineral matter, it will pose extreme challenge for further processing. So, that gives you an idea that whenever you are picking up materials, what properties you should look forward to? You should look forward to materials which has lower alkali content, lower ash content, because otherwise it will create a lot of problems. And what are the problems now we are going to do? It leads to the clinkering, it leads to accumulation of slurries and sludges and everything. We will come to that now, okay? Because one of the classic feature of most of this alkali metal is that they can act as adhering agents. So, if you have to calcium, they will chelate things, they will accumulate things. Okay. Use magnesium. So, there are several such, they have a very unique chelating property. They can pull, like they have arms like this, they can pull things, and these particles from this much they become this much, and they start clogging the different ports through which there is a gas release, there is the air input, and likewise and so forth. They all get clogged, and the walls of the reactor gets clogged. So, it is very, very critical while you are picking up the feedstock, you have to really understand that this ash content should not bother in the processing. Okay. So, now coming to the mineral matter and how it is posing challenge. So, the first thing is to deal with the oxidation temperature is often above the melting point of the biomass. Okay. Oxidation temperature is often above the melting point of the biomass, or rather biomass ash, leading to clinkering, slagging problem as well as slagging. Okay. Okay. In the so this is a new word which we haven't come across in the hearth and subsequent, I will explain this, subsequent feed blockages. So, hearth is essentially, all of you have seen the fireplace, where really the burning takes place in a fireplace, that is called the hearth area. So, the oxidation temperature is often above the melting point of the biomass ash. So, what happens? Think of it, just read through the line and realize. So, the oxidation temperature is often above the melting point of the biomass ash. So, what will happen? The biomass ash, the alkali will melt, because your oxidation temperature is higher than that. If your oxidation temperature is here and your biomass will be melts here. So, automatically what will happen? All the biomass ash which is present there is going to melt here, and if it melts, it forms a thin slimy fluid, and this kind of fluidic material forms a coating on the surface of the mixing along with the tar and everything. It forms a coating, it blocks the walls, it blocks the pipes and everything, and that is why this leads to what we talk about is these two words, clinkering or the slagging. Slag is basically that thick high viscosity fluid which is flowing through, clogging the different orifices likewise. Okay. So, that is the process, and clinker occurs. So, let me add one more thing. Clinker occurs well ash percentage is more than 5%. I am just showing is more than, okay, when ash is more than 5%. So, which is essentially leads to the formation of, if it is more than that, it forms alkali oxides and salts. I told you that most of these materials have this peculiar chelating power. First of all, these alkali metals form oxides, sometimes they form lot of chelation, chelate with other different kind of functional group of organic material, they form this bolus kind of thing, they form slug kind of stuff, and it really clogs the system. So, one has to be very particular, one has to really know from the beginning that what kind of what are the properties of the material what we are using for it. Okay. So, next in the category comes the volatile compounds. So, in terms of the volatile compounds, say for example, you have wood, they have lot of terpenoids, okay, and terpenoids are volatile materials. So what is very important is that if it has lot of volatile material, then the gasifier what you are choosing for your industrial work, it should be able to destroy the tars, which is basically the product coming from all the terpenoids, and should be able to destroy the heavy hydrocarbons, because these are source of different kind of volatile material, and most of these volatile materials are not very healthy for human to be exposed. They create a lot of irritants, they create a lot of skin rashes and lot of other problems and lot of lungs related issues. So it is very critical from the environmental pollution point of view as well as from the sustainability point of view that we should be able to remove or destroy these different tars which are formed. They are very carcinogenic too. So we should have a way to either process them or convert them into some user friendly product, or some way or other getting rid of it. It is exceptionally important from the green chemistry point of view. Okay. So now from the volatile compounds, we will move on to the particle size, which is the last parameter which has to be taken into account. Particle size. Okay. Now, in terms of the particle size of the feedstock materials, if you look at it, particle size depends on the size or the dimension of the earth, because where the reaction is going to take place, dimension of the earth, but is typically 10 to 20% of the earth diameter, earth dia. Okay. Larger the particle, so here is the catch. If you have very large particles like this, they will almost form a bridge like structure which will prevent permitting the movement of the gas and other things. Whereas if you use very smaller particle size, something like this, they will form a clogging. Here the movement will be restricted, and I have, this is kind of a repetition if you think of it, and here this will lead to a clogging. So we have to have a trade off in between the two, and if there are smaller particles and it leads to clogging, it leads to some other very interesting things which are very detrimental for it. It could basically lead to the available air voidage, leading to the very increased pressure drop, which is very dangerous for the system, pressure drop, and lead to a sudden shutdown of gasifier. So we really cannot make it very fine. Okay. Whereas if you have this large particles, what you will be seeing is that it will prevent the movement of the feed. So nothing can move through them. Okay. So what you observe in this whole process is this, there are kind of multiple points of trade off which has to be done. What kind of particle size you are picking up, what kind of gasifier you have, if you have summarized it, what kind of material you have, how much terpenoids and tars which is coming out of it, because more the tar you have to have a process to continuously filter it out, and since from where the gas is really coming out, you need particle filters in order to get rid of some of the particulate matter which are present there. So based on these parameters, based on this parameters as well as their pre-treatment, one has to decide what kind of gasifier we are going to use. So what we will be doing after this, we will talk about the design of different kind of gasifiers. which are currently being used all over the world. Okay. So, I will close in here. So, today what we have covered, let us again. So, we already did the introduction, basic chemistry, feedstock treatment, and today we talked about feedstock properties. Now, our goal will be to understand this interesting portion, which is the gasification types. Under this, everything you will be able to appreciate it much better. But what I wanted to highlight today is, please go through this part very carefully. This is very important, the basic chemistry. You should understand the basic chemistry, as I was mentioning today number of times. If you understand the basic chemistry right, then it will be very easy to correlate these two aspects very easily, that how the reaction is going to happen. So, that is why my take home message will be, those 4 reactions what we have talked about in the very beginning is what is most important for you people to look at, and those 4 reactions are here: partial oxidation, stage 2 oxidation. These are very, very critical, and this unique step where we talk about water gas shift reaction. Okay. So, I will close it here. Thank you. So, next we will follow with the gasified designs.